So you know how to steal bits from the host portion. But why do we care about that? Why does it mean so much to us? Because you have now the information you need to figure out how many subnets were created. Going back to an earlier example, we had the large 172.16.00/16 network, which we then turned into a /22, which gave us 64 subnets. Well, how do we figure that out? How do we know it's 64 subnets? Well, we have an equation that's going to help us here. 2 to the power of s equals the number of subnets created. Well, what is s? S is the number of bits we stole or borrowed. So if I was originally a /16 and now I'm a /22, how many bits did we steal? 6. 22 minus 16. We put that in the equation. 2 to the power of 6 equals 64. 2 to the power of 6 equals 64. So now I know how many subnets I created. I created 64 total subnets by borrowing 6 bits. Let's say we had borrowed instead 12 bits. 12 bits. So what would my new subnet mask be if I borrowed 12 bits? Be a /28. So we are a /28. Borrowed 12 bits. 2 to the power of 12 equals 4,096 subnets. Can you see how important it is to know your starting point now? If you're not sure how important that is, think about having the starting subnet mask of a /8 instead of a /16. So if you were a /8 as your starting subnet mask, /8 as your starting subnet mask, and you're now a /28, is it still 4,096 subnets? No, it's not. Because if you were started out as a /8 and now you are a /28, you would have had to borrow 8 bits plus another 8 bits plus another 4 for a grand total of 20 bits borrowed. So it'd be 2 to the power of 20 in that case for your subnets. That's a big difference, isn't it? Whereas if you're a /16, as we see here, and now you're a 28, it's 2 to the power of 12. What if you were a Class C address, like 192.168.1.0/24 as the starting address? Well, if you were a /24 as the starting address, and now you're a /28, how many bits did you borrow? 28 minus 24 is 4. What's 2 to the power of 4? It's 16. It's 16, right? So a big difference in regards to the starting point versus the number of subnets created. Now, why is that? Because a Class A address is huge. It's huge. There's so many host bits you can borrow. Class B address is medium-sized. Less host bits you can borrow from. And then your Class C address is small. Much less host bits you can borrow from. So if you're Class A, you can borrow, well, there's 24 host bits left over. If you're Class B, there's only 16 host bits left over. If you're Class C, there's only 8 host bits left over you can play with. So based on that number, determines the number of subnets you have with powers of 2. So you really need to know your starting point in order to get the numbers accurate and correct. So in this case, in our example, we knew we were a /16. 172.16.00 has a default subnet mask of /16. We needed to come up with, we said 64 subnets for our environment. So in that case, I know that 2 to the power of s has to equal 64. So I'm kind of working backwards here. You see that? I'm kind of working backwards. What I'm trying to figure out is what subnet mask do I need to support 64 subnets? So I'm Class B starting out. Class B default starting out. slash 16. I know I need 64 subnets. So 2 to the power of S equals 64. So 2 to the power of what equals 64? 6. 2 to the power of 6 equals 64. So now I know that I would take 16 plus 6 and get a grand total of 22. All right? So that's how I figured out the subnet mask based on the fact that I needed 64 subnets. So pretty simple equation. It's going to help you figure out how many bits you need to borrow based on the subnets you need to create, or how many subnets you'll get based on how many bits you borrow. How many of you have been in the industry for ages? I mean, since the 1990s, maybe even the early 2000s. This equation here may not be what you're used to using when creating subnets.